Okay. Now see, this is a circuit diagram of TTL NAND gate, which consists of four transistor, NPN transistor, 1, 2, 3, 4. In this case, Q1 is multi-emitter. Also, this consists of four resistor, 1, 2, 3, 4, and one diode D. Power supply is of 5 volts. Now, then draw two table of NAND gate. Here write y equal to A into B by, because this is circuit diagram for NAND gate. Therefore, we can draw. Now, see case table number one. Case number one, A equal to 0, B equal to 0. Then here write A equal to 0, B equal to 0. When A equal to 0, uh, when A equal to 0, this junction will act as a forward bias, reverse forward bias. Therefore, entire voltage will flow towards ground to point A. Same for B, and therefore, if entire voltage will flow towards ground from A to B, A and B, therefore, therefore, collector of transistor will be Q1 of will be 0. If 0 base of 0 Q2 is 0, therefore emitter is also 0. If emitter is 0 means base of Q4 is 0, therefore if base of Q4 is 0, therefore its output, that is Y equal to 1. Thus case number 1 is true. Next point is next point is a second point. Second point is value of A0 and value of B equal to 1. Then write A equal to 0, B equal to 1. When A equal to 0, therefore this junction will be in forward bias. Which bias? Forward bias. And therefore entire voltage will flow towards the ground through point A, towards ground through point A. Okay. And therefore, here you will get, therefore collector of Q1 will be 0. If which is also base of Q2, and if base of Q2 is 0, its emitter is 0, which is the base of base of transistor Q4. And if base of transistor Q4 is 0, therefore Y equal to 1. And hence, second case is A equal to 0, B equal to 1, Y equal to 1. Thus 2. Okay. Next is third case number 3. I will delete this. Case number 3 is A equal to 1. Then write A equal to 1. B equal to 0. B equal to 0. And see, when A equal to 1, therefore this junction will be reverse bias. Which bias? Reverse bias. But at the same time, but at the same time, this junction B equal to 0, hence entire voltage will flow towards ground through B. And hence again you will get voltage at collector of Q1 is 0. This if base of, which is the base of Q2, if base of Q2 is 0, emitter will be 0, which is the base of Q4. If base of Q4 is 0, therefore its output will be at logic high. That is why. That is case number. Okay, you can write this. And last case is when both are 1, that is when both are 1 means A equal to 1, B equal to 1, A equal to 1 and B equal to 1. And in this case, when A equal to 1, this is in reverse bias. Reverse bias means open switch. This is open switch. Again, B is also open switch. Therefore, uh, Therefore, there is no way to for voltage to flow towards ground, and therefore voltage will be due to this reverse bias of A and B. You will get voltage at this collector of Q1 will be 1, which is base of Q2. If base of Q2 is 1, then its emitter will be 1. If emitter of Q2 is which is connected to the Q4, and if base of if Q emitter of Q2 is 1, therefore base of Q4 will be 1, and therefore output of Q4 will be at logic low, that is 0. Okay, this is about the NAND gate um, working. Means here this which required 4 transistor Q1, Q2, Q3, Q4, but in this Q1 is multi-emitter, means which consists of more than one emitter terminal, and it consists of 4 resistors and 1 diode.